Before you take notes in this section, please make sure that you have printed out this version of the law of signs. There's also a second one that says the law of signs ambiguous case, and we will look at that after we've discussed this portion about the law of signs. So the law of signs is fairly simple mathematically. We are going to be looking at a proportion between the side and an angle of any two of these three fractions. So we need to have at least three of these components that I'm marking off right here. So we would need to have a side, so 1, 2 sides, 1, 2 angles. We need 3 of those 4 components, 2 sides, 2 angles. And then we'll look at how that translates into what types of triangles we are starting with to be able to identify, are we using the law of signs or are we using the law of cosines to find missing pieces in our triangles. So the law of signs works when we have, again, 2 of the 3. So 2 sides, 1 angle, 2 angles, 1 side, 2 angles, 1 side. And the way that we tell the information, angle, angle, side, or side, side, angle, draw the picture, label the information, and then figure out if the side is in between the 2 angles, or if we have angles next to each other and then a side off by itself. And when we have a scenario like that, we know we have the right material to set up the law of signs. So we're starting here with triangle ABC, and I'm going to do my best to draw a quick sketch in here. There's ABC, here's A, here's B, and here's C. Angle A is 70 degrees, angle B is 80 degrees, and side little a is 12 centimeters. Opposite angle A is little a, and we need to find all of the missing pieces. So from my very quick diagram here, I can see that I have an angle, and a side. So that would be angle, angle, side, which fits one of my options for using the law of signs. On the next page, I'll have a better drawing and then some more room to work out finding the other components of this triangle. So let's take a look. So the first thing that I can find very quickly here is that I know my triangle has 180 degrees, and I've just used 70 and 80, which sounds like 150. So 180 minus 50, 180 minus 50, 150 equals 30. So angle C equals 30 degrees. Okay, so I found one of my missing pieces. To find side B, law of signs, I've got little a over sine A equals little b over sine B. And now I can cross multiply. So 12 sine 70 equals b. Oh, I'm sorry, I've got too many 70s in there. This is supposed to be sine 80. Helps if you put in the right angles there. So 12 sine 80 equals b sine 70. Now to get b all by itself, I need to divide by sine 70. And we pull out a calculator to go figure out what b equals. And this is side b, so hang on just a second. We want to make sure our calculator is in degree mode because that's 80 degrees and 70 degrees. And make sure you close parentheses, like around sine 80, close parentheses. Otherwise, it's not going to turn out very well. And I got 12.6-ish. And then our unit was centimeters. So we have side B all set up, and we need to then proceed to find side C. I'm going to go back to my information about side A because that was, it's not using anything that's rounded. If I set up my proportion using side B, my value for B has been rounded. It is not exact. So I don't want to use a rounded answer to produce another one. So 12 over sine 70 equals little c over sine 30. And again, we cross multiply. And we get c all by itself. And let's see about what little c is. So 12 sine 30, closing parentheses when we put it in our calculator, is about 6.4 centimeters. So we have the three missing values that we were looking to find. This page just summarizes the three sides or the three pieces we were missing, the sides and the angles. And again, mentions, as we're calculating, please do not use rounded values. We have to use the exact values. So we have a new drawing here, and again, my triangles all look the same, so I will try to make 115 degrees there, something like that. So there's 115 at angle C. Let's call that angle A. Let's call that angle B. Angle B is 30. Side A is 30 centimeters. So side A is opposite angle A. And if I look at this, just to see what type of triangle I have angle, side, angle, which is one of the characteristics or one of the types that uses the law of sines to help us find missing components. So on the next slide, I have a better diagram, and I'm going to use the law of sines to find missing pieces. So as I'm trying to think this through, the first piece that's easy to find is finding angle A, because I've already got two angles. So 180 degrees, subtract off 115, subtract off 30. Let's see, 180, oops, wrong one. So 180 minus 145, I think that gives us 35 degrees. Okay. And the reason I had to find angle A, in addition to it being easy, was that I need to use little a and angle a to set up all of my proportions. Little a is my only side, and I'm going to have to use that to find side B and side C. So if I set up my fraction, I would have little a over sine of a. And I don't have to get little b next. I could go find little c next. So it really doesn't matter which of the next two sides I try to go find. This just happens to be in alphabetical order. So I'm looking for little b over sine of b. And then I'm going to cross multiply. And get b all by itself. And let's see what b equals. And it's about 26.2. And I don't know if I have a unit on this. I wasn't paying attention. To get little c by itself, I'm still using little a and angle a, because the little a was the only side that was given. I don't want to use the rounded value of 26.2, so I'm back with 30 over sine 30 equals little c over sine 115, and then cross multiply. And little c is about 54.4. So this slide just summarizes the values that we found. The next slide just talks about a couple of extra links if you need some additional information. The two examples that we looked at here were very clear indications of using the law of sines and being able to find the missing pieces. The next portion of the law of sines is when the law of sines gets tricky, and so we're going to spend much more time examining the tricky part of the law of sines. So let's go take a look at the ambiguous case for the law of sines.